Hello, my name is Andrew and my partner is Aiden, and the design pattern that we're presenting today is dependency injections. The topics that we are going to brief over today are the introduction of dependency injections, a real-life example of one, the pros and cons of using it, a simple implementation of dependency injections, a UML diagram of it and its relationships within it, and a conclusion. So what is a dependency injection? We should first go over what a dependency is. A dependency is a relationship between two classes or objects in which one component relies on the other to work. Thus, a dependency injection is a technique in programming where the component that relies on another component is handed the object. This promotes more abstraction and low coupling because rather than a class creating the objects that it needs, it simply is provided to them and keeps the jobs of each class separate. Additionally, these traits are also a big part of Solid, more specifically the single responsibility principle and dependency inversion principle. Dependency injections can take different forms. The constructor injection is a class or object that is provided with their dependencies through the constructor. A setter injection is where a class is provided with their dependencies through a setter method. The last type of dependency injection is an interface injection. Here, there is an interface in which other dependencies may inherit from. From there, the class that requires their dependencies take in objects from classes that inherit from the interface. For example, if fruit was an interface and apple and oranges were implementing fruit, then a fruit basket would take in fruits as its dependencies and thus takes in apples or oranges or etc. as their dependencies. A real-life example of dependency injections would be a scenario where you manufacture cars. In a scenario without dependency injections, you would create a different type of wheel per buyer request, meaning you are creating a new wheel each and every time a buyer wants a new car, versus a scenario where you are using dependency injection, you would buy wheels for the car based on the buyer's request. In the scenario with the dependency injection, you end up with much less coupling and more abstraction, keeping the jobs of manufacturing a car and wheels separate.
So what does dependency injection do to your code? So first and most, it will make classes more abstract and extendable. This is because the dependencies are no longer being defined inside of a class, but rather they're being supplied to them, so it can be extended to more types. This also makes the code more modular, which promotes the single responsibility principle, in the sense that the class is only going to have one specific function, and it also supports dependency inversion, which is saying that higher level classes depend on the abstractions of lower level classes rather than specific implementations. As we can see here, these classes are depending on the abstractions of these dependencies rather than their specific implementations. This leads to lower coupling, less dependencies, and make unit testing easier as well, because now that we're defining our own dependencies, we can create custom implementations of them. So maybe a wheel, instead of having an actual drive function, it's filled with debug information, we can build these mock objects and then pass them into the car class or our client class, so we can have a more easier to see testing output. And then it'll reduce code, specifically when in initialization, because there will be these injector classes, you'll learn about them in a bit, which take care of the whole initialization process. We don't do it ourselves. What are the cons here? It's going to make code more complex and also more difficult to grasp. This is because there's more modular components going on, instead of one or two classes. And also the effects of changes in your code won't be known until runtime. That's because it's only until runtime that the injectors are going to put all the code together and create the car object and return it. And then this might also, in turn, see some errors that would have been picked up at compile time not be picked up until you actually run your code. So when do you use dependency injection? So any classes that have dependencies that might change. A car might have different kinds of wheels. That's a perfect example. A screwdriver might have different kinds of heads. Phillips head, flathead, another great example. Programs that require low coupling as well. An example might be boilerplate or framework classes that are at more of an abstract level. These classes should not be very rigid. They should be more loosely defined and have the ability for users to customize their dependencies in a way. Maybe a vector class should have the ability for a user to supply whatever data type they want. Maybe not the greatest example, but you kind of get the idea. So what are some bad uses of dependency injection? Classes that the trade-off between abstracting their dependencies and the actual complexity of the amount of code you'll have going on might be too much of a trade-off. E.g., sometimes it's better to just leave the dependency in there rather than create the injectors and the implementations to avoid having to actually work around that ourselves. And then also classes that may involve editing the actual interface behavior and functionality. So if the wheel interface might have a constructor change or have different functions, this is going to conflict with the client code in a way that dependency injection is not going to help, because it's going to change the actual functionality, which might mean we have to change the client code itself. So let's look at some simple implementations. Here we have constructor-based and setter-based dependency injection. You can see one, we're passing in a dependency B for a constructor. The other, we have a setter. Pretty straightforward, but let's take some notes on it. So note in the previous examples that we are never instantiating the class B inside of it. When we are in the constructor, we're always passing in the type B. We're never instantiating one of ourselves. As such, we're independent of dependencies initialization. So that constructor would ever change, or maybe take a new parameter or have a different constructor entirely, the client code is not going to change. So now we need to look into how do we instantiate these. So we're still going to have something that instantiates the class A and also instantiate the B and supply to A.
Here's a simple UML diagram involving the client class, an injector class, and the service interface. From the diagram, we can see the relationship among the classes. For the client class, it is the user of the service and is dependent on the service class to function or do its job. Rather than creating the services itself, it receives the dependencies from the injector class. For the service class, it is the class that the client depends on. In this UML example, it is an interface. It provides or performs the functionalities that are required by the client class. Its services are then implemented by the injector class to be injected into the client class. For the injector class, it is responsible for creating or passing instances of the service and then providing them to the client class. Essentially, it plays as the middleman between the service and the client class by creating dependencies and injecting them into the client. The injections can take form in the different types of dependency injections that we went over earlier.
So now we've seen that, let's look at how dependency injection works with an interface. So we would create a service interface that represents the key functions of a dependency. So if it's a wheel, you might take out a function like drive. You would then create implementations of this interface, or as we've seen in the previous diagram, sometimes it's the injector's job that'll create these implementations. It doesn't matter which way you do it. So then you'll pass these implementations into the client via one of those constructors or setters that we have seen. And we can also make the service a polymorphic class as well and implement children of it rather than making the service an interface. The reason you might want to do this is like a wheel might have a lifespan, for example. It might have variables associated with it. Some abstract class, i.e. form of polymorphism, might be a better solution than an interface, because an interface is just a signature of a set of methods that have to be implemented. So then how do we instantiate the client with these implementations? That's where the injector comes in. So you also have to define an injector that instantiates a client for us, and it will return this. Sometimes this will be a function like get consumer or get client, or maybe get car as an example. And what the injector will do is it will take one of those implementations of wheel that we have seen, and it will put it into the car class and then return that object. In some implementations, as I've mentioned, the injector also is the implementation of service. And as such, there might be an extra method that says get car, which takes its own implementation and puts it into the car, instantiating it with itself. So some quick do's and don'ts for dependency injection. The big two are at the top. You should always pass in some interface or polymorphic class to the client constructor. You should never instantiate the dependency inside the client's instantiation. You should never instantiate the class B inside of its class A's constructor. You should pass it in if you want to follow this principle. You should choose a level of modularity that is appropriate for your needs. And vice versa, you should never overcomplicate your code with over-the-top dependency injection. What this is saying is you should always have some form of injector or interface that's being passed in, but the degree of modularity which you choose should be relatively appropriate to how important this is for your actual code. You shouldn't be overcomplicating your code trying to achieve dependency injection. So a quick conclusion, dependency injection is an excellent design pattern. It promotes modular code, as we've seen specifically dependency inversion and the single responsibility principle. Those are solid principles. Specifically for the S and the D. Dependency injection is a broad term and can be implemented in many ways. We have seen this being done with setters, constructors. We've mentioned how to use interfaces, and there's different, and how you represent the individual components and stuff is all up to the user to define. So now we're going to look at a code example, and this is the whole car and wheel example. So this main cloud function here, you can see the car, and you can see we are using constructor-based dependency injection. We're taking in a wheel object. We're setting this inside of ourselves, and then we have a drive function, which is operating this wheel using its drive function, where it's spitting out the car to some amount of miles. That's the testing function to actually run it. You see how do we implement wheel? This is an abstract class. As mentioned before, I chose to use some polymorphic structure here because wheels have a lifespan that references how long they can drive. Here's an abstract function, drive, which, as you'll see in the next two examples, will have different output depending on the type of wheel. We can also get its lifespan, and we can check how worn it is. So round wheel is the first implementation. These are the implementations of our service. Here you can see a round wheel has a lifespan of 40,000 miles, and here's the drive function. This logic is quite similar to the previous one, but it has specific print statements. And you can see if it can't drive the extra miles, it'll say pop. The square wheel has a lifespan of 20,000 miles, which is different, and it has different print statements as well, specifically saying square. So now we have to figure out a way to build the car, so we have injector classes. And what these do is, I chose to make it a static method, you don't have to, but it's going to instantiate the round wheel, and then it's going to pass it into the car. Square wheel does the same thing. It creates a square wheel and passes it into the car and returns it. So what we see here is in our main function, what I'm going to do is, all I have to do to create these cars is just call these injectors and getting a car from there, and it handles all the instantiation for me. As you can see, this is extremely modular, and as said, it reduces the amount of code you need to initialize stuff. This is a one-liner. And we're going to drive each of the cars, and we're going to see, what we should see is after 20,000 miles, the square wheel should pop, and then the round wheel should pop at 40,000. So if I run Java here, that's exactly what we see. They drive 1,000 miles here, then the square wheel drives until it pops. And now we drive them a little more. The square wheel is already out of its lifespan, car drove no miles. And then we drive even more, and now the round wheel has popped as well. Exactly what we expected.